Hello everyone. Now we are going to discuss how to convert a decimal number into any base. When I say any base, we have binary and we have, or the other one, we have octal, then we have hexadecimal. So, like this, how to convert the given decimal value into any base. So, if you look into it here, uh, let's say you take a number uh, 250 uh, 5 255. If you convert this number into a corresponding hexadecimal number, what we do, we divide this number by 16. So as we divide this number by 16, it yields a number of 15 as a quotient and also the 15 as a reminder. Now, but what do we need here is for our hexadecimal representation is when you say 255 is the decimal number and the equivalent uh, by the hexadecimal number will be FEF60. FEF16. So we need to have some means which will uh, interpret this 15 into F and also this 15 into F. Then we can easily say that it's going to be FF, the hexadecimal number for the given decimal number representation. Okay. Now, how do we do this? Already we have used a concept of how to convert a decimal number into a binary number in our previous video. When you watch it out, we can see that how stack is being used for converting the decimal number into a binary. The extension of that same concept only, we use it here for the decimal to any base as well. So only one difference here is that only we are going to mainly discuss here. So here we call the function as d2any and the number to be converted and to what base it's to be converted over there. And now if you look into it, we have the one array, one string called reminders. These reminders, please understand that these reminders will be used for the formulation of the any base numbers. Okay, so let's see how it's going to be done. So now here, as I told you, we just make the one representation over here to represent the number 15. So here the reminders are going to have a collection of numbers or characters from 0 to F. 0 to F. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and A, B, C, D, E, F over there. And being a string, this will have a index values. So these index values will be 0, 1, 2, 3, 4, 7, 6, 8, 9, and this will be 10, 11, 12, 13, 14, and this will be 15. So, like this, it will have an index numbers. Now, the index numbers are positioned in such a way, or the remainders are kept in such a way that the corresponding index number will give the hexadecimal representation. For example, you know that decimal number 10 is represented as A in hexadecimal. Similarly, 11, if you take, it's represented as B in hexadecimal. Similarly, the 15 is the index value means it will give a value F over there. Okay. So that's the basic concept over here. And now what do we do? So after declaring the rem string, then we define a stack for our application. Then we ensure that the number is greater than 0, and we continue to do the iteration of dividing successive divisions as long as the number divided by base is greater than 1. So then the remainder will be stored here, and the number, that is the quotient will be stored in the number. The number will continue to get reduced. So when the number is becoming equal to 1, we will come out of it, and whatever the number is there, and that will be stored onto the stack. Okay. So once this is stored, all the reminders, including the last quotient, is going to be stored onto the stack. So once this is stored over here, the next what we need to do, we need to collect the reminders in the appropriate base format. For this, what do we do? We use one loop over here. We are just going to pop. As we pop, we are not going to pop directly the number. Instead, we use those reminder values as an index for the reminder string, and in that index whatever value is there, that's going to be used as a formatted values. So then by using the yes again and again, we are concatenating the values, and that will give us the required format values. Maybe a binary value or hexadecimal or even an octal. Any values can be easily done with the help of this simple concept over here by using one simple rems or reminders uh, variable as a string variable here. Okay. So here, if you look into it, we have used one function that is d to any, and any idea to what we are trying to convert? Yes, we are trying to convert a number 100 decimal into an octal value 8. That's a 8 over here. So that gets into here, get successive division, and the values are going to be popped from the stack. As the values are popped, we will pull the corresponding remainder values from the rems, and that will be returned to the calling function as an output. Thank you.